My name is Simon Jones. I'd like to show you today how we can use Navisworks to review models as part of the visualized walkthrough. Right, let's get started. This safe harbor statement is a legal disclaimer that boils down to this. Please don't make purchasing decisions based on any speculative comments made in this presentation regarding possible future changes or new features. My name is Simon Jones. I worked for Allsets for 35 years, where I had a variety of roles from product support, product development, technical sales and consulting. I left at the start of 2021 and I'm now an independent BIM consultant. I've been working with Navisworks since well before it was acquired from Allstet when it was an independent application. I'm based near Guildford in the UK. Autodesk accelerators are designed to help your team stay ahead of the curve with the latest workflows. They include courses, videos, and live coaching, which is what we're doing today. You can see a full list of topics on the Customer Success Hub. Navisworks can combine separate models from different disciplines into a single, lightweight, multidiscipline model. Not only can Navisworks import models from Revit, but it can also import many other different products and file formats. These include Autodesk products such as AutoCAD, Civil 3D, and Inventor, as well as non-Autodesk products such as MicroStation, DGN, ISC, and SketchUp files, to name a few. In this example, we'll be working with a Revit building model, but Navis could also be used to include a Civil 3D site model. The resultant model is lightweight and easy to navigate around, making it ideal to share with an extended design team and to support a design review meeting. A typical workflow for working with building projects has the following main steps. First, we export the models from Revit as a Navisworks NWC file. Separate discipline-specific models are combined together in a Navisworks as a single coordinated multidiscipline model. This model can be used to perform a virtual model review to demonstrate intent, present progress, and capture design issues. Issues can be exported as reports to the design team to be addressed back in Revit, and updated models can refresh the Navisworks model for tracking resolutions. Finally, the model can be published and archived as an accurate record of the design at any stage of the project. This accelerator provides a quick overview of using Navisworks on building projects. The workflow will be based on a commercial building designed in Revit. The Revit model has been split into three disciplines that are architectural, structural, and MEP services. The main topics and overall learning objectives we will be covering today are as follows. First, we shall learn how to export discipline-specific models from Revit. Then we shall aggregate the discipline-specific models into a single coordinated multidiscipline model in Navisworks. Before starting the review, we shall learn some Navisworks good practices in setting up orientation views and search tests in order to make the review process as efficient and streamlined as possible. Once the Navisworks model has been set up, we'll learn how to navigate around it to perform a virtual tour of the building. We shall learn how to take measurements of the model and to capture these as red line markups in annotated viewpoints. We shall learn how to export reports and publish the model to report back to the design team. Finally, we shall use Switchback to identify an object in the Revit model and demonstrate how to make a change and then refresh the Navisworks model. These are not all the features of Navisworks, nor is this a detailed training class. Instead, this accelerator is intended as an introduction of using Navisworks on building projects. Additional links will be provided at the end of the webinar if you wish to investigate Navisworks further. All products in the presentation are utilizing the 2022 versions. Let's take a look how we can export the discipline-specific NWC files from Revit and combine them together into a federated multidiscipline model with Navisworks for the review. When exporting a Navisworks file from Revit, you can choose whether to export all objects in the model or those visible in a view. The recommended workflow is to use the view option so that what you see is what you get. This will avoid unnecessary graphics such as scope boxes being exported to Navisworks. Whilst it is possible to include link files as part of the export, it is recommended that you have a single NWC for each Revit file and therefore do not export link files with the host. Then, before performing export, it is recommended that you save a 3D view with a name such as Navisworks Export, then switch off the links and hide the objects that you do not want to include in the export. The view should have detail levels set to fine so that objects such as pipes are exported in full 3D and not simply as centralized, which I'll now demonstrate to you. The Revit export options for Navisworks can be accessed from the export dialog from Revit or through options dialog in Navisworks. In most cases, you can stick to the default settings. However, there are two options that should be confirmed. Firstly, assuming the models are set up using shared coordinates, check that coordinates is set to shared. For models not using shared coordinates, the settings should be project internal. Under export, ensure the current view is set. Let's start by duplicating existing 3D view. And we're going to rename that one to Navisworks Export. To ensure all objects are displayed correctly, we're going to change the discipline to coordination. And the visibility graphics override dialog box, we're going to switch to Revit links and switch off the visibility of the links. Next, we're going to select on the levels and hide them from the view by category, and we can also hide the category of section boxes. So we're now left with just the model items that we want in our Navis model. If we zoom in, we notice that the pipes are actually only single line. By changing the detail level to fine, they're now fully 3D. Now we can go to the external tools and run the Navisworks export tool. First, let's check those settings. Coordinates are indeed set to shared, and we're exporting the current view. Just going to cancel that and generate a new NWC file. The existing one we had there is being overwritten, that's fine. Whilst in Navisworks, before starting, open the Navisworks options editor to the viewpoint defaults and enable the first three options of save, hide required attributes, override appearance, and override linear speed. These are global settings that only need to be done once. But what it means is your viewpoints will now save the visibility, color, and transparency of objects, and will also save walking or flying speeds of the walkthroughs and flybys associated with those views. One more default worth changing is to close NWC/NWD files on low setting that is found under model performance. When this option is enabled, it is possible to overwrite an NWC file that is loaded in a Navisworks session, enabling you to refresh the models with model updates without having to unload the models first. Typically, a federated Navisworks model is created by a BIM coordinator. Their role will be to create a coordinated multidiscipline model that can be reviewed by members of the extended design team, subcontractors, or client representatives. As previously mentioned, the design models can be a combination of different file formats such as Revit RVT, AutoCAD DWG, and ISC files. Whether these files are read in directly or exported from the design applications, Navisworks imports the data as an NWC file. This stands for Navisworks Cache. In this presentation, the model consists entirely of Revit models. When the NWC files are read into Navisworks, the file can then be saved as an NWF file. This stands for Navisworks File Set. This is a live file that simply references the discipline-specific geometry and metadata from the design application saved to the NWC files. If the underlying NWC files are updated, the updates are reflected in the NWF file, enabling an iterative review and update of the design. The NWF file also stores the Navisworks-specific data such as annotated viewpoints and comments that will be explained in the session. At any point, all the data can be encapsulated into a single NWD file, which stands for Navisworks Document. But perhaps Navisworks Distributable would be a better name. An NWD file is much like a zip file that contains all the design geometry and metadata, as well as the Navisworks-specific data such as annotated viewpoints and comments. Whilst an NWD file has lost its ability to update changes to the NWC files, it does mean it is ideal for archiving a state of the model with all the associated design review information for future reference. Not only that, an NWD file can be viewed for free by anyone using the Navisworks Freedom Viewer. To create a Navisworks model from more than one NWC, simply open one, then append all the others. If the Revit models are set up correctly with shared coordinates, they should align with each other in Navisworks. However, if they're not aligned, or there are different scales, you should review the unit and transform settings for each model. Please note that all Revit models should have the model units set to feet, since that is the internal units that Revit models are saved with. While models can be moved, rotated, and scaled through this dialog, the recommended way of aligning models is to use the Navisworks measurement tools, but we won't be covering that today in this presentation. We shall load the discipline model from Revit, starting with opening the MEP services model. You can see all the MEP services, spin around a bit. Next, we shall append the structural model. You can see the two models now together. And finally, we shall append the architectural model. This goes across the top of all those. And this we can save as an NWF file called coordinated.nwf. There are a number of view background options that can be set up according to personal preference. In this example, we're using the graduated option. The background options can be accessed from the view ribbon or simply right-clicking on the background. Key to running a successful model review is to set up some viewpoints that will enable you to quickly jump to areas of interest. This is especially useful if you have a large audience in the design review to avoid time being wasted during a meeting wandering around aimlessly in the virtual world. It is recommended to group together viewpoints into folders. The understanding of the capabilities of viewpoints is essential to know in order to use Navisworks efficiently. Not only do viewpoints save view direction, but they can also save object appearances, walkthrough and flyby speeds, annotations, and redline markups and comments. We shall use the Save Viewpoint tool to create a new viewpoint, and it's recommended you create a home view so you can return to it if necessary to reorientate yourself from the starting location. We can also designate this as the home view on the view cube. It also provides some organization for viewpoints. We should create some folders. We've created one called Import, Disciplines, and Orientation. To organize your viewports, we shall start by dragging all the imported ones into the imported folder. Now we're going to hide the architecture, and we're going to create some discipline-specific views. So here we're just seeing the structure and the MEP. So we're going to save this as a viewpoint and call it MEP plus structure. Let's just make the structure transparent so we can see the services behind the structure. And this one we're going to call MEP plus structure transparent. And if we just want to quickly see just the MEP, let's hide the structure and create another viewpoint, which we're going to just call MEP only. Next, we'll do a bit of housekeeping and review some of these important views. And a lot of these provide us no help whatsoever, so we're just going to delete these. I'm not going to delete them all now. But some of them, like in this architectural model, are actually some quite useful views. Like here we've got the one main entrance, workout room, pool room. And these I'm going to drag into the orientation folder so I can quickly find myself in the building. If I need to locate the library, I can quickly jump to the library view and I'm in the library or workout, whatever. Or I can jump to disciplines and quickly get a discipline view of just the MEP and structure, or I can return myself back to start by selecting the home view. Objects can be selected directly in the model or through the selection tree. The selection tree is a hierarchical structure that organizes the objects according to their source file, level, category, and family, if applicable. The alternative property view of the selection tree organizes the hierarchy according to the object properties and provides an alternative view of the data. Selecting an object in the selection tree will highlight the equivalent object in the model and vice versa. Whilst objects can be selected individually from the model or the selection tree, the Find Items panel provides an interface to search for items that match a search criteria. The example on the slide will find all items whose category is either duct, flex duct, or duct fitting. Once search criteria have been created, they can be saved to XML files to reuse across different projects. Use selection sets and search sets to group together items for reselection. Selection sets are named static groups of items based on a manual selection. whereas search sets are named dynamic groups of items based on search criteria defined using the Find Items panel. Search sets update automatically as the models change. You can export search sets to XML files for reuse across projects. Selecting a floor in the model, you see from the selection tree that it represents a composite concrete slab over a metal deck. Reviewing the properties of the metal deck, we can see that its name is set to metal deck. In the Find Items panel, we're going to use this to search for all items with the name that equals metal deck. And when we press the Find All button, it'll highlight all the metal decks. And we can save this as a search set, which we're going to call metal decks. If we change the Find Items to condition contains, and this time I'm going to use concrete, and do a find all, we can now find all items that have material that contain the word concrete. We're going to create another search set and call this one concrete, and this has highlighted the slabs as well as the lift shaft as concrete items. Next, if we take a look at one of the ducts, we can see that it has a system type of named supply air. So we're going to delete the conditions we have now, and we're going to choose the category of system type, name, and we'll say equals supply air. And do a find all. And this will find all the ducts, flex ducts, equipment that are on the supply air system, and you see them highlighted in the model. We change the value to return air. We now can see the return air selected, which we're going to save as a search set called return air. And finally, we'll change the value to exhaust. And we can create a search set for the exhaust air system. One more search set. We're going to change the, we can highlight each one of these search sets to reselect those items. Let's take a look at one of these columns. We'll see that has a material with the word steel in it. So we're going to change the category to search to be material, or item material contains steel. So now we're going to find anything that's made of steel or has a material assigned with steel, find all, and we see highlighted steel columns and braces. And in the properties panel, we can see that we found 2,607 items of steel in this model. Navisworks provides several options for displaying your Revit models that can help communicate the design during a design review. These include applying colors or materials to specific objects to provide identification, making objects transparent so that other objects can be seen in context behind them, sectioning the model for cutaway views. Individual objects can be assigned an overriding color and/or transparency, such as this example of a see-through green wall that we shall now demonstrate. An alternative to assigning color and transparency overrides at an individual object level is to use the appearance profiler that can assign color and transparency overrides to the whole model based on their properties or their inclusion in a selection or search set. This is an important and powerful tool for assigning consistent standardized colors that will help object identification. These standards can be saved as a DAT file that can be used across multiple projects. To demonstrate object overrides, we should simply select the wall and use the override item to first override its color to green. And then we're going to override its transparency. And as you can see, we can now see through our green wall into the offices behind it. To return this wall and any other walls that have color or transparency overrides, then you use the reset all appearances on the home ribbon. A more practical example is to set the glass in the windows to be transparent. However, there's a lot of glass in this model, so selecting them individually would not be a practical solution. If we select one of the windows, we can see from its properties the material property called glass cast grey, which we copy to the clipboard. In the appearance profile, we're going to use that property to search for. So we're going to use item material glass cut grey, and we're going to set a light grey colour and set a transparency of 75%. Test selection will test what items were found with that property. And then when we hit run, that transparency has been applied to all our glass objects in the building. So we can now see through our windows. We can also use the appearance profile in conjunction with the search set we just created. So what we're going to do is take each search set. Here we have exhaust air. We're going to make these dark green. The return air, we're going to set to orange. Supply air, we're going to set to light blue. For the metal deck, use brown. And the steel, we shall use pink. Finally, the concrete, we're going to set that to grey, but we're also going to make it transparent as well, so that we can see through our concrete to the items behind it. Once we've done that, let's just test one of the selections. Return air, that's fine. We're going to hit run, and all those colours will apply to those objects. So now we can quickly see, we're going to identify our various duct systems based on their colours. And we can quickly see what is steel, what is concrete, and we can even see through the concrete to get context of our objects. There are two main render styles that control how Navisworks display objects. The shaded option displays objects using their colour and transparency settings, whereas the full render option displays objects using materials such as concrete, brick, or grass, which will override any colour and transparency settings. Should you wish to generate renders with extra realism, Navisworks also includes a ray trace renderer that will provide enhanced lighting and material control. Whilst this is not as fast as the standard renderer, there is an option to have the renders generated in the cloud, which is significantly faster and doesn't tie up a desktop machine. Here we see the model displayed using the standard shade mode using the default colours assigned in Revit. To view the materials, we select the full render mode from the viewpoint ribbon. The MEP ductwork and equipment is displayed in white, making them difficult to distinguish from other objects. So we shall select the ductwork and apply a polished brushed metal material to them. And to the MEP equipment, we shall apply a nerd metal material. You can now see the differentiation between the metallic objects and the bricks and concrete used in the building fabric. However, the polished metal of the ductwork still looks anything but realistic. For further realism, we shall switch to the render ribbon and run the render in the cloud tool. The rendering cloud dialog will confirm the number of cloud credits that are available to us, and assuming credits are available, you can start the render process. The process will take a few minutes, so we enabled the email me when complete option to notify us when the render is completed. This process has been sped up for the purpose of this demonstration, but if a short while later an email is sent with a link to your gallery where you can access the final rendering, which we're seeing now. The cloud rendering deals with lights and reflections in a more accurate way, and we can see from the large ducts on the roof that the polished brushed metal finish is closer to what we would have expected. The View section feature enables you to slice through the model in order to cut away non-relevant geometry or view hidden features such as cross-section of the structural composition of the building. You can define single cut planes, such as the example on the slide with a vertical selection through the length of the building, or a horizontal section to reveal details below floors and ceilings. You can also inspect riser spaces and elevator shafts by using the box section. To create a sectional view, select the Enable Sectioning on the Viewpoint ribbon. First example, the section is aligned to one of the walls and slices the length of the building at that point. Use the Move gizmo. The section can be repositioned as required to open up the model, and this can be saved to Viewpoint. We'll call this viewpoint Long Section. Next, we'll set the section to align to one of the roof surfaces. And again, we can move the gizmo to reveal the detail below the roof. And this section we'll call horizontal section. Now quickly spin the building around and use the section tool just to hide the back wall. So first we're going to create a section from that back wall and just push it back a bit to reveal our duct risers. What we're going to do is we're going to select a few of the ducts just to indicate the extents of the duct run that we want to look at. We're going to enable the box section and we're going to fit to the selection. So now we have a section box automatically wrapping around our duct risers so we can inspect the whole duct riser run in context with the building fabric and see if we've got any clashes and things without the rest of the building in place. And this one we're going to call riser section. Now there's saved viewpoints, we can instantly restore any one of these sections. So hit the back at home, there's our long section, our horizontal section, and our riser section. An alternative sectioning to view underneath or behind objects is to simply move objects that are in the way using item transformation tools. This example demonstrates how to lift off the roof of the building, enabling the reviewer to view underneath it, while still being able to see the roof and associated surfaces. In the front view, we're going to use the selection box and simply select all the items that make up the roof and be saved as a selection set that we're going to call roof. Then using the Move tool in the Items Tools ribbon, we can simply drag all the items up clear of the rest of the building. Switching to 3D, we can now visualize the top floor under the roof while still seeing the roof. Since the selection set was saved, items can be reselected and moved again at any time. To reposition the roof back into its original position, we shall use the Reset All Transform tool, which is found on the Home ribbon. Or an alternative to moving items out of the way is to temporarily hide them. You can select individual items or those in selection sets or search sets. A particularly useful tool is the Hide Unselected tool, so you can quickly isolate some chosen items by hiding all the others. You can use Unhide All to restore the visibility of all items. To hide objects, we simply select the individual items such as this front wall, then select the Hide option from the menu. That has left 3 windows, so she will hide those too and clearly see into the rooms behind. Looking down on the building, we may want to see under the roof again. We're going to recall our roof selection and simply hide that. And now we can got an unobscured view into the rooms underneath the roof. We've covered how Navisworks can be set up to display the model, so now we shall discuss how to navigate around and within the building in order to review the model. A necessary part of model review is to efficiently move around the model, and Navisworks provide 3 different navigation options. Which you use will be down to personal preferences and some subtle differences. Originally, Navisworks included just the navigation bar, with options such as zoom, pan, orbit, walk and fly. However, once the product was acquired by Autodesk, the steering wheel and view cube were also included to provide a consistent 3D navigation experience across the suite of Autodesk applications. When walking and flying, there are additional realism options. Collision controls whether or not you can pass through objects such as walls. Gravity gives you weight and pulls you down onto the surfaces and is used in conjunction with the collision option. Crouch enables you to duck under low items with limited headroom. Third party allows you to navigate a scene from a third-person perspective, looking over their shoulder. Familiarize yourself with all 3 options as they have their advantages. Using the Orbit tool from the navigation bar, we can freely view around the building in any axis. If you wish to keep the model vertical, use the constrained orbit. If we switch to fly mode, we can swoop down to the entrance of the model from our bird's eye position. As we get closer to the ground, we can enable the walk mode. And if we switch on gravity, we'll gently lower ourselves onto the ground, enabling us to walk up to the building. We can look up and down using the mouse scroll wheel. You can switch to the basketball view and now stand in the corner of the room, standing still, looking around so we can inspect the interior of our rooms. These are the navigation bar features. Next, we're going to switch to the steering wheel and load the full navigation wheel. Here I'm using the orbit tool. Has the advantage that all the options are on the cursor, so you can quickly change between different modes. So now I'm going to switch to a walk mode, walk along. And if I stop, I can switch to look up and look around, and we can look about anywhere where we're standing. Handy feature is this rewind option. So if you get lost, you can get yourself back to where you were before. Finally, we're going to have a look at the view cube. Here we can select pre-selected views, corners, tops, front, left and back. And you've got a nominal compass direction, so you can orientate yourself according to what's considered north. Or we can drag the ring around and spin our model around using the view cube as such. If we return to the exterior, I'm going to show you the realism. Here we've got gravity and collision switched on. Gravity will also enable us to walk up steps. There we go, up the steps. The collision means we won't walk through walls or even this glass door, so we will literally bump our head against the glass door. If we want to get through that glass door, we can switch off collision, or you can simply enter Control D, and that will switch off collision as well. Now we can go through. To get an appreciation of the space, we're going to switch on the third person mode. Now we're looking over the shoulder of someone walking around the room, and we can see for ourselves how much space they have walking around these desks and down this corridor. In any view and during walkthroughs, you can optionally display the grid lines that have been imported from the Revit models, helping you to locate your position or the position of objects in the model. Simply hovering the cursor over an intersection point will display the grid reference. You can enable the display of grids through the Show Grid tool on the view ribbon. In the first instance, the grid is being fixed to 0 basement level of the structural model, but we can change the level to some alternative levels and notice how the grid is redisplayed accordingly. When the mode is changed to below, the grid below the current camera eye level is displayed, and as we move up and down the model, the grid automatically updates to the relevant level. As the cursor is hovered over an intersection point, at the base of this column, it displays the grid location in the tooltip. Once the Navisworks model has been prepared with viewpoints and search sets, it is ready to support the model review process using measure, markup, tags, and comments features. The measure tools can be used for measuring distances, areas, and angles of the model geometry. A unique feature is the option to measure the shortest distance between two objects, and if, for example, you need the vertical distance, there is a lock feature to constrain the measurement to just the z-axis, as illustrated in the slide. That's measuring the floor to the landing rise of a staircase. Initially, measurements are displayed temporarily in the current view, but they can be converted into red lines and saved to a named viewpoint. Measured distances and angles can also be used to move and rotate objects or a complete model that is not coordinated to other models. The Navisworks redlining tools are fairly basic, but that does make them very easy to use, and it will not take long to get familiar with tools such as cloud, ellipse, arrow, and text. Once a red line is placed, it is automatically added to the current named viewpoint, or a new viewpoint is created if required. Red lines disappear when you navigate away from a viewpoint, but reappear when that viewpoint is returned to. In this model, we're performing a walking inspection of the MEP services and structural model. The first issue we notice are some disconnected ducts, which we will mark with a simple ellipse red line. When this is added, a new view is created, but will rename to disconnected ducts. Moving on, we stop at the foot of the stairs to check the staircase width and the landing rise height above the floor. The point-to-point measure tool is used to display the staircase width. At this point, the measurement is temporary, and to make it permanent, the convert markup tool is used to create a new red line. And that creates a new viewpoint. Next, to measure the staircase landing height, the point-to-point measure tool is once again selected, but since we only want the vertical distance, the z-axis is being locked. First point selected is snapped to the bottom of the staircase, and the second point selected is snapped to the top of the landing. This measurement is then converted into a red line markup and added to the current viewpoint, which we'll call staircase measurements. And we shall continue our virtual inspection around the floor. Looking up, we see a number of pipes running through the supply air ducts. Since there are several interferences, we should use the cloud tool to highlight them all and rename the new viewpoint to duct interferences. Next, I would like to check the gap that has been allowed between the exhaust and return air ducts to check there's sufficient room for installation that hasn't been modelled. To get a good view of the duct risers, we select a couple of the duct segments from each of the risers and then use the constrained orbit to spin around them to get a clear view from the other side without losing focus on the ducts. As suspected, the two risers are very close together, and using the shortest distance tools, we confirm that the gap is just 57 millimeters or just a couple of inches, which is insufficient for duct installation. So we'll create a new viewpoint and call this one insufficient clearance for duct installation. To organise the review, we shall create a new folder called Project View with the current date, and we're going to move the new viewpoints into that folder. We can quickly play back the issues found simply by reselecting any of the project review viewpoints. Navisworks Comments tool enables the reviewer to add additional information to viewpoints as well as other Navisworks features. As comments are added, they are automatically assigned an author from the Windows username and the current date and time. Each comment can have a status to indicate whether it's new, active, approved, or resolved. The Find Comments tool can be used to list all comments by name, date modified, status, and/or author. Opening the viewpoints from the model review, you can simply add a comment to each one in order to provide additional information to the issues found. We can add a comment, basic modeling issue to be resolved by the HVAC modeler. Next up, let's take a look at the duct interferences and add a comment. Pipes to be rerouted below the ducts, and we can go around adding comments to our other viewpoints. The tags feature combines the features of markups, viewpoints, and comments into a single tool to further enhance the review meeting efficiency. Once again, we are performing a model review by walking around the model and looking around. This time, as we spot issues, we select the Add Tag tool. Here we simply pick a point where the issue is, and then a point with a small number tag. As soon as the tag is placed, the Comments dialog box is opened for the reviewer to add a relevant comment. This process is repeated for other issues as they're spotted, and the tag ID is automatically incremented so that each tag is assigned a unique number. It is also given to a corresponding viewpoint name, for example, Tag View 2. The Find Comments panel can be used to list all these comments, not just the ones we just created with the tags, but we can also see the comments that were created with the previous review we did walking around the building. Once the model review has been completed, it will then be necessary to report findings back to the design team for issues to be resolved. Annotated views can be exported as simple images, or all the markups and comments attached to viewpoints can be written to a viewpoint report in HTML format, which include viewpoints thumbnails. However, the most powerful option is to publish the review to an NWD file that encapsulates all the information, including the actual status of the review design and all viewpoints, comments, and markups. The NWD file can be viewed but not edited by anyone using the free viewer called Navisworks Freedom, enabling anyone access to the information. In the case of sensitive information, an NWD file can be password protected to protect confidentiality or given an expiry date so that it is not inadvertently referenced after it is considered out-of-date information. Switchback enables you to select an object in Navisworks and then locate and zoom into the same object in Revit. Revit must be installed and running on the same machine as Navisworks, and it is necessary to first run the Navisworks switchback command in Revit so that it is primed for the switchback. To perform a switchback, locate an item in Navisworks and select the switchback option from the item menu. Revit will then attempt to locate the equivalent object in Revit and zoom to it. Using the Revit section box tool, we'll create a section box around the selected object, which helps in isolating it from the rest of the model. Once the issue has been located and isolated in Revit, make the necessary change to fix the issue. Then switch to the Navisworks export view to export an updated model overriding the existing NWC file. Back in Navisworks, use the refresh tool to reload any updated files, review the change, and update the viewpoint comment status accordingly. Highlighted is a duct segment that is causing a disconnect with the rest of the duct run. In order to locate this in Revit, first we shall switch over to a Revit session that is running on the same machine as Navisworks. From the External Tools menu, select the Navisworks switchback. To prime Revit, to wait for the switchback call from Navisworks. Back in Navisworks, select switchback from the duct segments menu. Now return to Revit and the equivalent duct segment has been selected in the view that matches the viewpoint pad in Navisworks. However, we can't see the duct segment as this view includes the room ceiling. With the duct segment still selected, select the selection box tool from the Modify ribbon. This will create a new view with the section box tightly cropping the duct segment. We shall zoom into the section box and use grips to expand it sufficiently to reveal more of the duct run. To resolve the issue, we shall delete the disconnected segments and add a new duct segment from the end of the rectangular duct to the connector of the round T fitting. Satisfied that the issue has been resolved, we shall open the Navisworks export view and export an updated NWC file overwriting the existing one. Once the NWC file has been written, we shall use the refresh tool to reload this and any other updated files. Now we can see the duct run disconnect has been resolved, and we can update the comment on the viewpoint, changing its status to resolved. This change is also reflected in the comments list. Hopefully this session has provided a good overview of using Navisworks on building projects for performing model reviews with visualized walkthroughs. Today we covered the exporting of discipline-specific models from Revit, preparing the federated model for review in Navisworks, performing a model review with annotated viewpoints and comments, recording and sharing findings with the extended design team, and using Switchback to find an object in Revit, and then refreshing the Navisworks model with an updated design model. As I mentioned at the start, this is not all the features of Navisworks, nor was this intended as a detailed training class. So we shall now highlight some additional resources that can support your learning. Please refer to the links, courses and coaching classes that are available to you. I'd particularly like to point out the AU presentations as there's access to many Revit and Navisworks related class recordings from current and previous Orsett universities. The Navisworks Freedom download, share this link with your extended design team and clients so they can freely view the Navisworks model, as well as comments and markups, and check out the other courses and coaching that are all available on the Customer Success Hub. So unlock the potential of all your Orsett technology through these additional courses and learning paths. Hopefully this session has met your expectations. I wish you a good day and success in learning Navisworks for reviewing Revit projects. If you'd like to contact me directly, please do so. My email address is simon@aecbimtools.com.